Hey everybody, you guys able to hear me okay? Great. Alright, let's go ahead and get started. So first, just course logistics. Just a quick reminder that your peer review assignments are due on Sunday night. So please do those, and if you have any problems accessing the prototype you were assigned, try to reach out to the person who made it first, and then if you still have problems, let me know, and we'll make sure that you can access it to review it. Okay, other big announcement for today, Exam 2 has been posted. So I posted that a little while ago. It'll be due on Tuesday by midnight. So it's 9 questions. They're short answer. Like the last exam, it's open book, open notes, open internet. Only note there being that you can't get somebody else to do it for you, and you can't plagiarize by copying and pasting from something on the internet. And if you use any external resources, please cite them. So that's all listed there in the exam for you. I've included 1 extra credit question at the end. I think you'll enjoy this exam. It'll be probably a little less tedious and not as long as the first exam. So it's oriented around prototyping and developing an evaluation for a hypothetical prototype. So it should be pretty enjoyable to complete. If you have any questions, send me an email or let me know. We'll meet again on Tuesday before the exam's due. So you will have a chance to ask questions in class then. But if you need anything sooner, just let me know and I'll get back to you as quick as I can. All right. So last time, we were looking at prototyping tools in depth, and I realized that I forgot to go back into XD and make the scrolling thing work. So I just wanted to show you that real quick. So here I am in XD. I've just got one artboard here, and if you remember last time I had just taken this square rectangle utility. It just made me a rectangle shape here, and I just turned it gray so I could see it. And then I used this repeat grid feature in XD just to drag it out and get quite a few of these. So then I wanted to do a horizontal scroll, and what I'm going to do is just to make it clear what's going on here is I'm going to make this into a group. So I'm going to hit group here. So now I just have a group. And you can see we have these scroll properties here. So I'm going to do a horizontal scroll in this one. And it lets me set the scroll group view frame here. So I can just drag it where I want. Now when I prototype that, I will be able to scroll that in that direction. Okay. So what I can also do though, is if I take this group and I'm just going to copy and paste it. So now I have 2 of them, and I'll paste it once more so that I have 3 of them. So now if I preview this, they all independently have just a horizontal scroll. What I could also do is I could take all 3 of these together, right click on that and make a bigger group, and then I could take that group and give it a vertical scroll, set its viewport maybe just to show 2 rows, right? So now when I preview that, I have individual horizontal scroll separate from this vertical scroll. So now what I could have done as well is rather than do all of that, I could have taken my rectangle, let's just draw this out here, let's make this one red, and do the same kind of repeat grid on this. So maybe like this, like that. Okay, I'm going to make that a group just for clarity here. And then I could also set for the whole group, maybe just a both vertical and horizontal scroll. And so I'm going to set my viewport here similar. I'm just going to like that. But you'll see the behavior is a little bit different. So on this one, I've kind of just got this pan scan, right? Because the whole group is having this scroll, whereas this one, I have this row by row that's separate from my overall scroll. So that's what I wanted to demonstrate last time, and I forgot to go back to it when we were doing the demo. Oh, there's a question. The voice interaction with the prototype in XD can be kind of Wizard of Oz. Can we use this point to answer the question in the exam? Yeah, you could. I think, yeah, and just be sure to get the second part of the question too about, you know, when it would be good and bad. But yeah, definitely, because I know some of you will probably mention Wizard of Oz in answering maybe the previous question on the exam. So yeah, if you do that, you can, you know, refer to that same answer. You can talk about XD, like you said, and the voice interaction there, and just be sure to describe when it would be good or bad to use Wizard of Oz as well. But yeah, good question. Okay, another question. Oh, this is about scrolling. Okay, so to make the scrolling possible, you have to use another frame, not a group component on Figma. In Figma, yeah, you use frames in Figma. So the groups by default don't scroll. So in XD, the groups become scroll groups automatically. So yeah, it's a slight difference. Okay. Going to jump back to slides. Let me know if you have other questions as we go. So, there we go. Okay. Today, got like 3 separate things that I want to try to do, and I'll go in this order. Hopefully we will get through all of them. We may not make it all the way through Social HCI. If we don't, we'll pick it up next week to finish up. But I want to finish the evaluation example we were doing a couple of classes ago with Survivor Buddy. Then I want to talk a little bit about data visualization, and then start talking about Social HCI. So let's jump back into that example evaluation that we were talking about. If you remember, we were talking about using the Survivor Buddy robot for search and rescue, right? Coming up to a person, like we see here. We were talking about scaling its behavior as it gets closer to a person. So we talked about implementing the system to constrain how the robot moves and behaves depending on how close or far away it is to a person. And we talked about comparing 3 different ways of doing that for our study. So we had these 2 mappings, and then our control condition would just be to always move with the same intensity no matter how close you are to a person. So we talked about planning the evaluation. We came up with 3 conditions. So that was our control condition and our 2 scaling functions. And then we talked about what we would measure, number of participants, protocols, and approvals. So for conditions, there's the 3 conditions. We had the linear scaling condition, and we had what we called the logarithmic-based scaling, and then we had the constant and no scaling approach. And if you remember, our scenario was a building collapse, search and rescue. In terms of what we were going to measure, we talked about quite a few different surveys that were administered for this study. So first of all, we had just kind of self-report questionnaires, the main measure in this study. We, of course, collected demographic information about the participants. We did a Big 5 personality inventory. It's a pretty common measure. And then we did some subjective evaluation of the robots. And in addition to the self-report questionnaires, we did an interview with participants after the study, and we measured some behavioral aspects, some things that they did in the study, and physiological, so their respiration, their heart rate, skin conductance as they were going through the interaction. And remember, this was a between subjects study, so everybody just saw one condition. They didn't get to compare them within their own experience. So we talked about calculating how many people you need to participate in a study, and in particular we discussed that for a study you want to have a certain statistical comparison done, so you can specify some of these things about your study, specify what kind of allowable error rates you want, and effect sizes that you predict, and you can use some software that will use some statistical models to tell you how many people to put in each condition. And an important note about that, I don't know that we talked about this in detail. So inferential linear statistics are based on a normal distribution, and typically we have the central limit theorem, which says that we can apply these rules of a normal distribution as long as our sample exceeds a certain threshold. What I want you to remember is that you should always test to see if your data is normally distributed. If it's not, you need to use some robust statistical methods rather than just the default linear inferential stats. But in general, kind of a rule of thumb with the central limit theorem is that you need about 30 samples per condition, and that's not entirely accurate for everything, but that's kind of just the quick number that people remember. But you calculate the actual number depending on different attributes of your study. So we also discussed writing a protocol and how important that is for a study, both because it tells you exactly what to do. It keeps everything consistent across participants, which is especially important when you're doing between subjects study. And it's also a big part of getting ready for your ethical approvals that you'll need to conduct a study, which we'll talk about that a little bit more today, hopefully. And so it's also useful for people replicating your study. So ethical approvals, we talked about in the United States, that's the Institutional Review Board, IRB. And that's a board of people. When you're at a university, the university will have its own IRB composed of faculty members and usually an external person or two from the community. The whole job of IRB is to review studies to make sure they're safe and ethical for participants. So they'll want a lot of detailed information. They may have questions. You may do back and forth revisions, and ultimately they will you'll get to a point where they approve the study. It may have to be reviewed a number of times in different ways. And then as long as you're running that study or looking at the data from that study, you'll have your IRB for that study will be open. And so that means you have to submit periodic reports, status updates, and if anything happens in your study, any adverse event, anything you weren't expecting, you have to let them know pretty soon after it happens, and then they'll review that event and decide what kind of actions you need to take, if you need to change your study, or what should happen there. So that's important. And I should say that pretty much every country and every jurisdiction that you're in will have some form of an ethics board that's similar to this. And private companies typically will use an IRB that they pay to be a member of, so that because they're not a university that's doing research constantly, they'll typically kind of use their own IRBs that are for commercial purposes. Or they'll partner with the university in a lot of cases to have people at the university conduct the study. So we also talked about implementing an evaluation. And so that in this case, when we're talking about using Survivor Buddy, that the evaluation itself can be as complicated as prototyping or building a system. And so in the case of this this study with Survivor Buddy and comparing these proxemics scaling functions, we really had to do a lot of prototyping and kind of a full design iterative approach to designing that study. And so you have to think about a lot of things while you're doing that. You have to think about how long it's going to take for a person to go through it. You have to think about keeping things reliable. What if something fails? Kind of all the contingencies. So we looked at that environment for Survivor Buddy in this study. Here it is with the lights on. Here it is from the other side, where you can see the lighting and the projection system. Here's a view of what the robot, the path that it approaches on towards the participant with the lights visible. Here's the control area, one of the control interfaces for the study. And so this is all part of that evaluation system development, right? So you've got to build this system, this software as well, that lets you conduct your actual study. And here's more of what the robot actually looks like when it's in that environment. And last time we watched a video of that. So then we talked about actually running that evaluation. So kind of the first thing you do in any evaluation, and so we're talking about like a controlled study here, but thinking about just some user evaluations that you might do for your project, right? Even if it's just going to be a few people that you know giving you feedback. If you make up a written evaluation or a survey, you want to do at least one kind of pilot run, right? You want to check and make sure you actually ask the questions you thought you asked and that you're recording the data in the way that you thought it should be recorded. So as the studies get bigger and more complicated, you do more and more of these pilot runs. And that's usually where people who are not directly involved in building the study or facilitating it, but are people that might be working in the same research group or might be friends, will come and go through the study to help you find any issues that might exist before you actually run the actual participants that you're going to use to evaluate the study. So then we started to talk about analyzing data from the study. And so kind of what we typically do if it's a bigger study is when we set up our measures, our surveys, first of all, we know how we're going to analyze it. We kind of know what we'll do once we have data. And we do that ahead of time. That's important because you need to think about things and make sure you ask the right questions and that you'll have data that actually can give you a result. There's nothing more frustrating than a study that's poorly designed and you have data at the end, but you can't answer the questions you need to answer because you didn't think about how it would be analyzed and there's some confounding variable or something that wasn't collected or manipulated right. So that's important. But when we get the data back, typically like in a big study, we'll do kind of a first look at the data, which involves basic descriptive statistics, some sensibility checks, making sure that, if we've gotten a survey item that you can answer 1 through 7, that there's not a 77 in there or something like that. Which I should say you should check these systems ahead of time, especially if you're using like a software-based surveys, which is usually what we do now, because you need to make sure that it's recording correctly. And I've seen studies where we've done studies in our lab where people have coded a variable wrong or something and ended up not capturing one of the item responses because another one was overwriting it twice or something, which is really upsetting when you've run hundreds of people and then you realize that. So better to know sooner than later. So with a study like this, we put together typically a report that just kind of gives some insight into those variables. So in this case, this is just the demographics of gender that participants self-reported in this study. So it's just showing it male versus female, which are the two that were reported in this study, and how that was set out among the conditions. So in this case, we did not counterbalance for this. We didn't attempt to make sure we had an equal number in each of these conditions. This is just a result of random sampling, and it's pretty good. So you can see, in general, there were more males that were in the constant case than females. So that could be important, right? So if we find something that has a gender effect, then this might matter. So we also can give descriptives as histograms. In this case, we asked people what their experience with video games was on a 1 to 7 scale. So here's that distribution there. Another question that's important for robotics, we asked people if they own pets or spend a lot of time with pets. So it's just a yes/no response. And then you can see, for some of the more complicated measures that we have. So in this case, we had this group we call a comfort, which is made up of these individual items from the surveys that were administered. And you can see here, here's the descriptive values, the means for each of the conditions. So you have your conditions here. And then we look at just a kind of basic statistical test. In this case, it's an ANOVA because there are 3 conditions here. And we compare conditions to each other. So you see that these are shaded in a diagonal because you can't compare constant to constant, linear to linear, logarithmic to logarithmic. But we can compare constant to linear. And so that's the p-value, the significance value for that comparison. And so that lets us know if there are differences that are statistically significant there. And you can see also we have overall significance to know if there's any difference at all. In this report, there's just a kind of a textual summary included. And this is done for each item. And I'm just showing you a couple of pages from this report. So you can see how that's reported there. Here's another common way of visualizing things. So this is a box plot. And so you've got your mean as this line here. I think this is probably 1 standard deviation worth here, maybe. Not entirely sure. But this gives you kind of your spread of values that you measured. So this is by condition, so constant, linear, logarithmic, and this is comfort level. So you can see in general, comfort going up across these conditions. And then like here, this is an outlying data point, participant 36. So this is a common visualization. And I should say that these visuals, these are from SPSS, which is a stats package commercial software from IBM. It's a really commonly used one. So after we look at kind of the basics, which might be all we need if we're doing kind of a simple user evaluation, right? We might be able to look at, I don't know, like timings and compare 2 groups and see that they're, far enough apart that there's a difference. We might even just be looking at percentages compared to each other. But when we have, a user study, an experiment, and we want to, statistically analyze it a little more and publish the results, then we do a little bit of a deeper analysis. So typically we start with manipulation checks. So manipulation checks are questions that check to make sure that the participant actually experienced the condition that you expected them to experience. So in this study, we asked some questions about, I think it was like, how much do you agree or disagree? The robot moved faster as it got closer to me. The robot dimmed its lights as it got closer to me. There's a set of them, right? And that lets us know that the participant actually perceived the experience at least somewhat as it was intended. So if you take an online survey, sometimes you might see a question that says like, answer this question with 5 or something, or it might just ask you a really odd kind of basic question. Usually those are manipulation checks to make sure that people aren't just clicking through the surveys. And there are a lot of other ways you can look at that. But that's important to know. And we also look at item grouping and reliability. So, we looked at like that comfort measure, right? It was made up of several questions combined. So you can calculate if those questions are getting a similar response, basically, to know that they're a reliable group, that they represent the same concept. So that's important. Checking assumptions. So we talked about checking just common sense check to make sure that data is where we expect it to be, it's on the right scale, but also things like, is your data normally distributed? Can we run these tests? Are they appropriate for this data? You want to also look at potential covariates. So in this case, we use a lot of demographic factors as covariates. So we collected things like what people reported their gender as, what their age was, their experience with video games. We asked them things about, we did the kind of the personality inventory, the Big Five, to get that measure. And so we can look to see if there are any characteristics that span across conditions that we manipulated that influence our outcomes. And so those would be covariates. And then we apply our statistical test. So I've just extracted some of these tables from the paper about this study to give you an idea of kind of how this goes. So this first table here is showing you the means and standard deviations for each of these areas across each of the three conditions. So it's pretty straightforward. You can look at it and you can see, just the average value across these conditions. This table too is the same thing, but what we've done is put the statistical test comparing all of these, the results of those tests, the values that matter for those here, and I've shaded the ones that are significant. So sometimes we see a significant difference between some conditions but not all. So in the case of the perceived intelligence of the robot, there was a significant difference between the constant no scaling case and the logarithmic case. But there wasn't really a difference between linear and logarithmic, or even between linear and no scaling. So the distributions were similar enough there. Whereas if you look at like proxemic awareness or submissiveness, there's an effect all the way across that's significant. And then here's a few more of those that you see are just significant across two groups. So we talked about the covariates, right? So here are some things that for this study we measured about the participants, and this is what they were correlated with. So we asked people, what they thought the robot's role in the future would be, and we found a positive correlation with how much they enjoyed participating in the study, which is kind of intuitive. People who had a positive outlook on robots in general enjoyed it more. Whereas we saw a negative correlation with stress, which also checks out with in terms of enjoyment. If you're lower stress, you're probably going to enjoy things more. So you can kind of see that between those two. And then we see a bunch of positive correlations here. So here are some of the Big Five personality traits. And we see that those have positive correlations with some of these things that we measured about the robot and about the study experience in general. So we do see some gender covariates as well, where we had an effect just in general. People who reported being female also were more likely to report the robot's intelligence as being higher, and males were more likely to report being stressed. So these are relationships that exist across conditions. So it's important to report those, because it can give you a little bit of interesting insight. So in terms of qualitative insights, here's one thing you can kind of do. You can take the interviews that you do with participants, transcribe those into text, or if they've typed in responses, you can just take that text directly, and you can do, in this case, this is just a word cloud, right? So words that were used more frequently are bigger in this visualization. There's a lot of ways you can style this. You filter out kind of the words that are really, really common and don't mean anything. So in this case, these are the words that were most frequent for the logarithmic perception-based case. Here's the linear case, kind of similar. You see you've got one scary in there, maybe an apprehensive, and the constant case. So you can see there's a bit of a difference there. We've got quite a few more negative words here. And you could also analyze this with stats. You could look at the counts of this kind of sentiment that exist and analyze that a little bit more formally. But this is kind of a easy way to get some intuition on what people were thinking between those conditions. You can also look directly at some of the things that people said during the interviews. So these are a few quotes from people in the constant condition, talking about, they think it should move more slowly as it gets closer to people. It's kind of nice to see that when that's what you're studying. And talking about being nervous as the robot approached them when it was, moving quickly. And worried that the robot might hit them in that case where it was moving just at a constant rate of speed as it came up to them. So once you've conducted your study and analyzed your results, typically if it's academic work and it's something that you want to publish or put out there, you'll start. You make presentations typically to your research group or wherever it is that you're doing this. One thing that is pretty common at academic conferences are posters. So usually 3 feet by 4 feet kind of size posters that people make just describing their work. So here's one describing this study, kind of just goes through everything, presents it in a easily consumed format. And then you typically will ultimately write a peer-reviewed article. So in this case, this is the article that's associated with this study, which you can find here if you are interested. But it kind of presents all of this data. It presents a more detailed version of it in a format that allows you to really explain all of your results thoroughly. So from this study, just to kind of give you the takeaways from it, we did verify that it does in fact matter how a robot behaves depending on its distance from a person in a search and rescue environment. We showed that the different scaling functions did have different results that they generated, so that's important. And we would give a recommendation to people, building platforms like this or platforms that are going to get near people, to start with using that perception-based, that logarithmic-based scaling. So it's important that we might not know, there might be better approaches, and it might depend on things like what the robot looks like and what the person's condition is. I mean, this is kind of a weird case where a person's laying down. That's probably not the most common default. But based on the data that we have from this study, we would suggest that people start with kind of the best result that we had. So let's shift gears a little bit and talk about data visualization. So we talked about this a little bit in terms of, that graphs and visuals are a really intuitive and helpful way to understand data that you've collected or evaluations that you've performed. But we also want to be cognizant of the fact that our visuals can be very misleading, and we can do a lot of damage with bad visuals. And I'm sure you've seen some bad visuals in your lifetime. I do want to mention, if you're interested in visualization, kind of the go-to resource on this is Edward Tufte's book. Well, he's written a number of books, I should say. This is kind of the classic, the visual display of quantitative information. It's a beautiful book. It's just a lot of visualizations and kind of guidelines on how to visualize things. Enjoyable to look at, and there's a lot to learn in terms of visuals. So I would recommend kind of a fun resource that has things up to date and just interesting things from time to time. The subreddit Data is Beautiful. You can check that out. Lots of interesting visualizations that people submit there, and a lot of original work too. So it's always interesting to see kind of what people are analyzing and the visuals that they put with it. I do want to talk about today kind of more focus on misleading visuals and just a few things about how visuals can be misleading. So some common things that you might think of when you think of misleading visuals. Scaling graphs differently can be problematic. Choosing an incorrect baseline can be a big problem. And just using the wrong type of visualization is also a really common problem. So I want to show you, I should mention before I jump into some examples, that for creating visualizations, and we mentioned this before, I think, some of the basic tools like Excel, Google Sheets, spreadsheet software generate some great visuals. There are also more specialized tools. So we saw some of the visuals that I generated with SPSS for that Survivor Buddy study. Those are just the defaults that come out of it, and they're pretty good just to get some intuition. You can push that further. You can make some beautiful plots using some of the plot libraries in R if you're analyzing data there. Also, there's just quite a few software packages dedicated to visualization. So Tableau is an example of one that's pretty common. And if you want to take a more programmatic approach, libraries like D3, JavaScript library, have a ton of options and tutorials and nice things that you can do with your data. So a lot of options for creating visuals. So I'll show you some simple visualization examples. These are just, this is one that I grabbed from my electricity usage. So this is showing over time. So these are days on this x-axis here. And these are kilowatt hours used based on the day. And they're connected as a line graph. Okay. And so this is just data the company that does my utilities here in Starkville. They have a web interface that you can export this kind of data from. So you can see on a daily basis how many kilowatt hours you used. You can also get some other interesting data with the temperatures kind of across days, like the high, low, average temperature, which you can see if you see this cycle here, right? That's mostly driven by power consumption used for heating and cooling. And so there's a seasonal cycle to that. I should say that we're looking at, let's see, this is August of 2014 all the way to February of 2018. So quite a bit of data here, and you can see some of these repetitive cycles. So kind of what sticks out immediately are these periods here, which you see them happen each year, and you can kind of guess what those are, right? So I know that you can't see kind of these dates, but if you were to zoom in and see these dates, you would notice that this is happening in March of every year. So you can guess that that's the time of year that we're on spring break, right? So probably a time that I was not here, right? And so I wasn't consuming much electricity if I wasn't actually, at home using it. You can see a few little deviations like that, and essentially are all times when I'm not at home, right? And so this is a simple example, and it's just something kind of random that I pulled that I had access to data about me, but it definitely can see things happening here, right? You can see that when these drops happen, that probably means that I'm not there. And so you could look at those corresponding days and kind of get an idea about maybe what's going on. Could be useful. And then, of course, we talked about that cycle, which if you were to plot it out against temperature, you would see that it tracks there. So really simple data, really simple plot, just kind of the default out of Excel there. But definitely you could tell a bit of a story with it. here's another story. This is from when I was an undergraduate, and this is my GPA plotted out. I should say it's plotted a few different ways. So the different colors are different series. And so I've plotted it by semester, okay? And so you can see that it dips down, goes back up here. The blue is just for the semester itself, and the gray and the orange are kind of cumulative measures. So they're different because your GPA can get kind of reset. In my case, when I moved to Mississippi State for graduate school, they don't use your past grades. They start you over. But you can see how like a low semester can pull down an overall GPA or GPR, and it can be hard to get back. So you can also look at this data and say, what was going on in some of these semesters. And I think I started in a research lab about here. So you can see where I cared less about class and then realized that I needed to care more about class so that it wasn't completely horrible upon graduating. But just a simple example, right? Just plotting out a measure over time to see kind of what patterns we pick up on. So let's look at some examples of how to mislead with visuals. So I've just pulled these from kind of just this little blog article. It just shows you kind of 5 ways that you might see misleading graphs, 5 common ways that people will mislead. So we talked about omitting the baseline. And I liked this this blog because it kind of gave really nice little examples that were easy to consume. So you can see that between these two, this one starts at 0 and this one starts at 50. And you get a scaling effect, right? Same data plotted out here. But if you were to look at it on this scale, which is more accurate, you can see that kind of how these differences actually behave. Here, where you're just looking at this small range, right, which may or may not be appropriate, it makes these differences obviously larger. Okay, so another common data visualization problem that we encounter, manipulations of kind of the y-axis here. So you can see, in this case, the difference between these. So compressing again the axis there to make the findings look more or less significant. In this case, this headspace here doesn't necessarily contribute to the data set, and it prevents you from seeing kind of the actual differences. So again, manipulation of that axis is critical. This time it was just scaling. Another common thing that we see is just kind of picking data that we like versus data that we, that doesn't fit with our story. So you can do this obviously by changing the axis and zooming in and cropping off things. In this case, that's what they've done, is they've just kind of looked at a range of data that shows this upward trend. Whereas if you were to look at the following data, you would see that that in fact is not the bigger picture. Okay, so here's one just using the wrong type of graph, which is kind of surprising that this happens more frequently than you would expect. But in this case, like using a pie graph, big giveaway is these numbers do not add up to 100%. So that's a problem, right? So this is the type of data that's being evaluated, should not be plotted as, the groups on a pie graph, because they don't together compose 100%, right? They're individual in this case. And one last one that sometimes is a little harder to catch, depending on what you're doing. So we have some conventions in general that we follow when we visualize things. So this is like in terms of density, like population density or something. We tend to have the darker shade here representing more density. It's kind of counterintuitive to do it the opposite way. It depends again on what world you're graphing data for, but you want to be aware of these conventions that might exist depending on what you're visualizing. So that's just a couple or handful of common data visualization mistakes. And just a little bit about data visualization in general. Like I said, there are great resources to let you kind of develop skills with that and learn things. And it's really useful in terms of especially looking at evaluation data of interfaces. But let's shift gears kind of into our third topic of the day and our main topic for today, and that's Social HCI. And this is a topic that I find really interesting and that's really important. So you can see here, this is a story, April 2019, where Facebook's promising that they're going to stop asking you to wish your dead friends happy birthday. So this is a collision of an interface and kind of social aspects of human life. And this is the kind of thing that you don't want the headline to say. And so when we talk about social HCI, this is just one small example, but this is the kind of thing we want to think about. Where does the technology intersect with kind of the social world, and how can we make sure that experience is what we would expect it to be, and what's positive for users? So, start by saying the reason we talk about social HCI at all is that humans are social, and we can't get around that. So, we're going to talk, as we go through this topic, kind of, we'll start with one of the more traditional things that we talk about, and that's technology facilitating social interaction. So, things like a telephone or FaceTime, or, kind of whatever technology you might use to allow communication to happen. So that would be like a remote example. We also have face-to-face communication, which first of all, we kind of have to understand how face-to-face communication works in order to develop technologies that are going to extend it or augment it in any way. And kind of related to that, we'll talk about co-presence, which is developing technologies that assist communication between people who are co-located in the same space physically. And then we'll move into talking a little bit about machines being social themselves, and kind of the social nature that can be ascribed to a machine. Some of the things we'll think about as we go through these topics. We want to think about how technology affects social interactions in general. We want to think about how it affects physical and psychological well-being. We want to think about groups that might be particularly vulnerable to bad technology, and how it interacts with social interactions. So in particular, like children. So we think about like designing a children's toy, what kind of principles should we bring with us there? We'll talk some about how technology can affect equality and fairness in society, and that's kind of has a social grounding to it. And then a little bit about kind of how our technology can moderate or mediate societal constructs like government and politics. So we see our interfaces and our technology popping up in these really important areas. So let's talk about social interactions in general first. So face-to-face conversations. We'll animate these people in here. So these are two people having a conversation. And you can think about people talking to each other. And you can think about the things they're saying, the actual dialogue. In this case, they're greeting each other. But you can also think of some of these other aspects. So things like the facial expression, where is your eye gaze, looking. So people tend to look at each other you look at a person's eyes when you talk to them. You usually kind of you look at them, and then that's a fixation, and then you avert typically, and that's kind of on a cycle that happens automatically. We definitely, there have been people who have spent a lot of time studying all of these things. So a few others, we know a lot about the nonverbal aspects of communication here, right? Gestures, posture. I have social distancing here. I should say that I made this slide before social distancing means what it so commonly means today. But talking more about the proximity of people, how much distance are they physically keeping between them? Typically that's kind of moderated by the relationship that people have, and usually by the culture that they're in, and even just the situation they're in too. So you behave differently at home than in the workplace, typically with a lot of these things. So here are just some example rules that we could think of if we were going to characterize face-to-face interaction between people. So we could say that people typically recognize the other people that are around them. They respond to questions. They use a turn-taking behavior when they talk to each other. They keep some social distance that's appropriate, and they use appropriate head and eye gaze when they look at each other. And so these are all things that social psychologists have spent a lot of time observing people, and lots of different people in lots of different places, doing lots of different things, characterizing how all of this plays out. And it's something for us to think about as we develop technology that's supposed to work with people, and especially technology that works with how they socially interact with each other. So I think kind of a good place to start is thinking about conversation in general, and kind of the rules that exist when we have a conversation. So if you just, this is just a hypothetical conversation, and if you were to look at it, there's three people here, A, B, and C. You can see these concepts of kind of like greeting people. This is kind of a common thing that people do. See things like people saying like, how's it going? Usually people just answer that with it's all good, no matter what. So you've already kind of got, some convention there that's going to occur. And when you're thinking about conversation in particular, so we're just thinking about face-to-face people sitting down and talking, there are kind of three conversational rules that were, developed early on by people researching this, and they describe turn-taking behavior, which is common, and it just emerges among groups when they speak. So more than two people speaking, right? And you can characterize it with these three basic rules, so that the current speaker will choose the next speaker, usually by verbally indicating that who the next speaker will be. Sometimes it may just be looking at someone or gesturing to someone. Then that person may decide to take on that role, and then they'll continue to speak until this all happens again. Now you have some situations where people might interrupt, or there might be things that are higher priority, but this accounts for kind of basic face-to-face conversation. So you can think of turn-taking behavior that occurs, and you can see, right? Those are back-channeling sounds that we tend to make when we speak. And if you think about them, try to consciously think about the fact that you do that whenever you're speaking. It will make you uncomfortable, as I am uncomfortable now thinking about that, trying not to say which I would be embarrassed to count how many times I do that. Hopefully it was not too bad, right? But we all do these things. These are back-channeling behaviors. They're verbal. Typically, if you go and look at a conversation that people have, you transcribe it, you'll see all of these kind of weird disfluencies that occur, and we do a lot of high-level processing that just makes that work out for us when we're engaged in conversation. But when you look at the transcription of it, it's kind of a disaster. And so that's an interesting thing to think about when we're building technology, especially technology that's going to engage in conversation directly, which we haven't been doing for that long, but now we are doing a lot more of it with things like assistants, smart assistants in the home, smart assistants on your phone and on your just regular computer. That's become a big thing, right? These are verbal interactions that you have with these assistants, and in some cases, like in a home, right, that's even a special scenario where it's not just one user interacting with the voice assistant. It might be several users. It might be a family of people in most cases that may interact simultaneously. They may talk to each other while they're talking to the virtual assistant. We've got to think about how people go about having conversation when we think about things like that. Also, we think about things like rituals. We talked about greetings. Things like saying bye or see you later, that comes up. We also see people using nonverbal indicators, like these implicit and explicit cues whenever they're needing to get out of a conversation. If I look at my watch, that's usually a sign that I'm thinking about time. If it's not just a notification on my watch, I should say that's a little bit different. But there are behaviors that people have, verbal and nonverbal, that are trying to cue the other people that they're interacting with. So we also see breakdowns in conversation and how people recover from that, and how they make sure that they're understood. We also see people using things like basically saying what or I didn't understand, asking for clarification, and we'll see people saying things in different ways to make sure that the message is received clearly. So we thought about that face-to-face. So kind of it's interesting to think about it in terms of other mediums. So whether that be something like using a phone, which is just kind of audio medium, something like email, which is a message that's typically composed with a little bit of thought. People typically will write the email, then they'll kind of scan over it before they send it, in comparison to something like a text message or an instant message that's kind of just in the moment, but in text form. People definitely review that more than what they say verbally, but there's a distinction probably between email versus kind of a more quick form of text messaging. And then thinking about things like using something like Skype or Zoom or WebEx or whatever to have video calls with people. And kind of how does that shape the conversational rules that we have? So we can definitely say that when we take away modalities, like we take away the video channel, right, or the visual channel, that people are not able to get those cues. So if you're just talking on the phone, then you kind of only have the verbal cues that are there. And if you're talking just using text, well, you might start to use emojis or something like that to kind of supplement the message that you're conveying. So it's the fact that the medium that you communicate over is constrained by the design choices and the technology constraints that the technological constraints that the medium has. And so when we design interfaces that facilitate communication, we kind of have to think about these things as we design them to know what the best choices are going to be. So let's think about remote conversations in particular. So the idea being here, people are at a physical distance that is great enough that they will use some form of technology to communicate with each other. So just some quick examples: email, video conferencing, any kind of direct messaging, instant messaging, stuff like that. We consider that remote conversation. And when we think about it in comparison to face-to-face conversation, we kind of think about the similarities and the differences between each of those platforms. So I want to talk about, in particular, the idea of a video phone or a visual phone, and kind of the history of the idea of just communicating through both a visual and auditory means synced together. So you might think of something today, like FaceTime or any kind of real-time video chat like that. Previously, we kind of had the same software constrained to our computers. We had it in enterprise phones, and even way back we had these concepts of having these home video phones. So I'm going to show you a video, and this is one of the earliest demos of a video phone. It's from 1955, so please remember that everyone here is from 1955, and they're not nearly as enlightened as we are. So forgive them for some of the things they say, but let's take a look at this. Maybe.
First demonstration of the telephone of tomorrow at the Western Electronics Convention in San Francisco. It's the often forecast Videophone. How does it work? Just lift the receiver and you see your own image. This feature's for the girls. At long last, a reason for the primping that usually precedes a woman's phone call. No picture is transmitted over the line, though, since no call is placed. Then dial your number just as with an obsolete old 55 model phone. And when your party answers, there he is, almost as big as life on the 10-inch video screen. The system could have its disadvantages as well as virtues, but there's plenty of time to iron out problems in human relations. This hookup would cost $5,000 per phone today. So until the price comes down, the video phone remains the phone of the future. See you then. Good looking.
So were you guys able to hear that? I should have asked that earlier. Yeah, okay, good. So you heard all of their sexist comments. But point being here, 1955, people were thinking about this idea of real-time video conversation, and even speaking a little bit about maybe some potential benefits and some potential drawbacks to it. So thinking about kind of just our modern video technology that we use. Yes, those are true. Yeah, so 1955 is really early, right? So obviously this system was ahead of its time. It was supposed to be a kind of a vision of the future, which I guess to some extent is true. That we do use video chat a lot more now than we did in 1955. But thinking about what we use today, right? We've got a lot of most people could name off a few different platforms that let them do live video chat, just kind of off the top of their head, and it's certainly something that we would talk about differently than just a phone call, just an audio call that we might do, because there is that visual channel, but it doesn't necessarily, it's not the same as being there, right? There are limits to that. First of all, it's usually a 2D plane that we're looking at, a projection of the environment, and it's usually constrained by the form factor that it's in. So we can think about things like if you have like FaceTime on a mobile device, and we're moving that around to talk to somebody, versus like a conference room that's set up with a telepresence kind of system that's fixed and installed in the environment. There are differences there between what we would expect, but we see overall benefits as you open up these lines, these different channels of communication. There are some interesting trade-offs. For example, there's a lot of research into people when you use video products, right? So in general, we don't like it if people can see us, but they're not broadcasting back themselves. So this is kind of an interesting finding. People will find it a little bit creepy or invasive in some cases, that they are, remote people are seeing them, but they're not able to see the video feedback. It's kind of an interesting effect, but it's what you would expect. So, we get things like that coming up. Kind of on the positive side, when we think about things like communicating with a younger person, like a child, right? The video technology is better. It allows a person to point at something or to visually show you something and kind of collaborate in that way, which is useful for adults too. But particularly for children, where a lot of what they do is kind of more visual, especially as they're developing language skills. So, it's kind of empowering in that sense, if we think about it. But let's think about also kind of going beyond just supporting conversations. So let's think about, in this case, not so much live video, but conversations, or beyond conversations, I should say, on social networks. So think about things like Twitter, or Facebook, or Snapchat, or Instagram, whatever, kind of the major players that we all know, and think about the widespread adoption they have, and kind of how they're used, right? They have something more than just communication, right? So when we think about Twitter today, right, there's news that will break typically on Twitter before it's reported by, a major news network, like a 24-hour news network, or, a major, media publication. And oftentimes, if you want more direct information about something, you can use a social network to kind of directly access people who at least claim to be plugged into whatever event or thing that's occurring, right? So we can get on these social networks and pull up live video of something that a random person is streaming out to us, right? That's pretty powerful, especially if we think about using kind of the data coming in from social networks, both the text and the video and the images, as a sensor for what's happening in the world. So for example, we certainly see this being used for people who work in disaster scenarios. So in the United States, like FEMA makes use of a lot of social media data to kind of assess the spread of maybe a disaster. Maybe you've got like a weather event or an earthquake, something that occurs. That data is definitely used and examined for that kind of thing. But we also know kind of the downsides of this, because these social networks are just kind of algorithms operating over this data that's being supplied by people who are willing to supply it. That data could be anything, and there's not necessarily anything to say that it's accurate. There are certainly going to be biases in the data that you get into your system, and biases in the algorithms and the way that you process that data and choose to present that data. And in a lot of cases, you might just be subject to what we would consider an attack, right? Where someone wants to spread misinformation or cause concern artificially. So that's kind of a negative side to think of as well as we look at social networks. So this is, I just pulled this, I think this is from yesterday. So right now, there's I'll say a news article. There's an article that's been published by the New York Post with data that's relevant to the election that's going on in the U.S. right now, or alleging to be relevant to it, right? So recently, in the past couple of days, this particular news story started to be shared on Twitter and Facebook, obviously. And these are both platforms that are currently engaged in kind of a social dialogue and a discussion about how do we regulate information that's being presented on our platform. And in this case, last I checked, Twitter at least was taking a pretty strong approach to just not allowing links to this story to be shared on their platform. And so that's kind of interesting for a number of reasons, right? We can, it's a big thing right now because it's an election in the U.S. and people, whatever your political leaning might be, right? this is obviously a thing that's going to be charged for a lot of people, right? But I think as people who are looking at this from an HCI perspective, right, looking at this as people who design technology, you've got to kind of think about how do you make these decisions? And we've certainly seen, the major social networks try to figure that out, right? And they haven't taken an approach of let's just present whatever someone posts and just push it straight through, right? Kind of just like the idea of a pipe of, being a utility for people to move data across. And there are all of these kind of ethical and legal and moral, issues as you start to moderate content, right? But when we think about the social interaction that's occurring there, right, and how we might design an interface and consider some of these things, it's something you've got to be really careful with, right? And in this case, a lot of it is about judging content and moderating content. But there are decisions that you make in the way that you design an interface, right? So for example, think about an interface that attempts to consolidate like a single news story versus showing you duplicates of it. That might have an impact. If somebody were to say flood, one of these social streams with misinformation, it might be helpful that you designed a system that is already eliminating duplicates, right? And clustering information and presenting it to the user for a better user experience, right? You don't want to repeat the same information over and over. It may have some social upside to it, or at least kind of limit the negative impact that you might have. So this area is big, and it's an active area, and it's certainly an area that we all have opinions about each of these things and how we feel about it. But it's something that we can't ignore as people working kind of on the human-computer interaction side of things. So I think I'm going to stop here. We will talk about Facebook's violation of basic ethical research principles when we come back, when we meet again on Tuesday. So let me just kind of jump to the end of these slides here, just so I can show you kind of what's coming up. We'll pick back up on our Social HCI. All right, there's our schedule. So this is what we've got going on until we meet again on Tuesday. So please remember to get your peer reviews in if you have peer reviews to do. So those are due on Sunday. And then focus on doing exam 2. That'll be due Tuesday at midnight. If you have questions, email me as they come up. Really try to take this time where we have no homework, no reflection, no quiz still, to work on your projects, get those further along. If you have questions on that, technology problems, whatever, email me, let me know, and get your exam done. So we will meet again on Tuesday, and we'll pick up with Social HCI. We will meet virtually. Right now we are in a little bit of a trend upwards. So for us, for right now, virtual is going to be the safest way for us to go. We'll keep an eye on that, though. So that's everything I've got for today. If you have questions, I'll hang out for a couple of minutes, but otherwise, I will see everyone on Tuesday on WebEx. Bye.